So this is a little quick video of setting up Blender to cut things for Klipper, which is what I'm using for my laser now, and it's working pretty well. Blender CNC has some surprises, although it's been around for a while. It's got a few rough patches, but now that I'm used to using it, it's great. And it's all integrated with Blender, which is really nice. First, we'll start by setting up our machine, and I already installed BlenderCAM. Once you install it, you can come over here, click on your render properties, and change your renderer to Fabex, and that'll show you, you'll probably default to Eevee. Once you go to Fabex, you'll get all these details for the render properties. We already have this cam machine set up. That's our other router, though. We're going to go to Grogu, and that is still not saving the settings. There's a bug file about settings savings. Klipper needs to run on Gravos, so plug in the dimensions for your machine's work area. You want to make sure we're not outputting the tool definitions. It doesn't really matter because Klipper will ignore them, and we definitely don't want to split file. Now you can see our machine. It doesn't highlight even when it's selected, but once you select it, you can locate it, and we'll just set it to -280/2 and then -310/2. We'll stay in top view. Maybe it'd be nice just to set up a little box. We'll just do a small, like 50 by 50 by 25 box. We'll do it in 3 mil wood. No labels necessary. Sometimes you may have to work with this burn setting if you're trying out the boxes. Anyway, there's our box. Let's just grab it all and we'll just say A and G, locate it roughly there in the middle. We'll just slide this down a little, make a new collection. We'll call this outside. And we'll call this inside. We're going to take all the inside pieces and put them in inside. And then when it leaves us for our outside pieces, 1, 2, 3, 4, 5. So we'll begin by setting up our operations. BlenderCAM consists of operations and then chains, which are made up of operations. So an operation is going to happen here in our operation setup. We've got one here called OpCam Machine 1. We'll just rename that outside so it's easy to recognize. And we'll take instead a collection of objects and we'll use our outside collection. We're going to set up to cut on the outside of our outside cuts. We're going to do a count of 3 for our laser, and we'll leave some distance just so we can test that everything's working. We're focused at 5 millimeters. We'll start at 5 millimeters. And we'll run it a custom 5 millimeters, no layers. And then for Klipper, we're going to go M3S 255 M5 and M3S laser on delay is 0. The diameter is 0.18. And the feed rate, we'll do this at 480 millimeters per minute, which is 8 millimeters per second. The spindle speed doesn't matter. We probably should output a header. It depends on what you've set up on your machine. Usually what I use is just a macro for start, print. And so that's our outside. Now we'll just duplicate that and call this one inside. Add a collection again, inside, just as we imagined. This should all be pretty much the same. We're going to cut on the inside now. Do not overshoot. And we're going to cut at 5. We got an operation depth of 5. Move at 5, cut at 5. And we're going to go down to 5. We're not changing height. We need to. We just need to be where the laser's focused. Feed rate 480. Okay, so now that we've done those, let's create a new chain. This is going to be our BOX. And then we're going to add our operations. Let's add the inside and then the outside. It's entirely possible you might have accidentally put the outside first. Probably not the best idea in case pieces fall through and change position. So we'll move the inside to happen first, then the outside, and we're ready to calculate our chain paths. So it looks like you can see 1, 2, 3 lines around there. And then if you come in here, you'll notice that there's only 2. That's because our path is wider than the space. So here's some of the sticky parts of this whole situation. Sometimes if you're not selected on anything, it won't want to make paths. Then it also likes to stick them into collections, which is a problem when you're using the collection as the container for the operation. I find that it works the best to select something in another collection, hit that, and then see, even though we were in a different collection, it still shoved these into the inside path. Sometimes I have to make another one and just call this ops, maybe whatever you like. And let's see if we can get them to run in there at that point. Now we're not running because we don't really have an object selected. So let's try that again. We come to inside here. Our distance between is 0.1. We got outside is 0.1 in our operations. And then we can run our chain. Once we have something selected, calculate paths. And now you can see we've got our 3 lines there. Now, of course, we don't really want those 3 lines, so we'll head down to our operations this time. We're going to make this 0. You'll notice that it goes to 0.01, which is the smallest that BlenderCAM will do. Not perfect for the laser, but not impossible. Let's select our cam paths. There's our tool. There's our box. It looks like our whole cam path is 1, 2, 3, 4, 5 millimeters above the area. It's pretty nice too. If you're using different travel heights where it needs to lift up, you can see all that in the cam path as you span around. It's not like watching the tool move, although it does actually have a simulate button as well. This is a great little dialogue as well. It looks like the simulate didn't show anything this time. Oh, that's because there's no depth since we're making a laser cut. In other things, when you're doing the CNC, the simulate works a lot better. One other error that you will see is when a file is unsaved, it'll often say that it can't output the operation. Read-only file system, that means we need to save the file. Instead of having 2 operations, we can parent the interior pieces to the exterior ones. And this might not always work, which is why I didn't want to demo it the first time through, but it usually will. So we'll put all of these objects into here. They're all in the same collection. And then we'll just rename this first. That's fine. You obviously don't have to rename them, but just so it all makes sense. We can take and select these, and that one, and then we hit Command P, and then objects, and we'll go through and do this for these other ones. The object, and that should leave us with 5 parts. If we run our path, you can see our path is indeed on the outside of the piece and on the inside of our holes. Just make sure when you're using this option that you have inside out checked here. Things should be inside out, and that should cut the inside holes before it cuts the exterior pieces. Depending on what kind of surface you're working on, that can make a difference where you might need to get those removed. Let's take a quick look at the G code just to prove things. Got a G21 millimeters, G17, G90. The nice thing is if the Klipper doesn't know G codes, it will just skip them. This all looks great. We've got the laser coming on and off. 12 laser on. We've got some 0 pauses. This G4 is a pause. I don't think it'll actually read it because it's got an O in front of it. So you might want to make an alias to that in your macro. Let's see what we got. 0, we got 1 of 50. And those all G4s. Looks like they're all G4s. So it doesn't look like it's putting out anything. So that's it. I don't think Klipper will load an NC file, so you'll have to change the extension to .gcode. And this should just run on the laser and cut out some really nice little boxes. Cheers.